Alright, let's continue with the another experiment after open circuit test, and that is short circuit test. Right? Now, short circuit test is an experiment that the whole objective is to find the equivalent winding resistance at the high voltage side and the leakage reactance, equivalent leakage reactance at the high voltage side. Okay? Why the high voltage side? Because short circuit test often the experiments performed on the high voltage side. I still remember the parameters. Alright, this is the core loss resistance and the magnetizing reactance and the low voltage side, which we use open circuit test to find just now. Alright, and we lump the parameters R1 and R2 at the high voltage side. Now my primary is high voltage. So we do the experiment on the high voltage side, and short circuit test, instead of leaving it open circuit, we short circuit. We short circuit. So on the high voltage side, we short circuit it. So that is the experiment. Okay, and if you do recall in your EL Tech what a short circuit does, so if I have a short circuit, the current will definitely pass through my short circuit, right? And therefore ignore this, isn't it? Am I right? So these two parameters are therefore being short circuited, and that is why in your short circuit test, these two parameters disappeared. Alright, and our equivalent circuit is just simply two parameters in series, right? And the voltage, we call it short circuit voltage, short circuit current. Alright, again, if I put the voltage at 0 degree, then the current is minus theta. Why minus theta? Because it's an inductive circuit, current lags voltage by 0 degree, right? So in the short circuit test, we have a power meters that measure the power, the voltmeters that measure the power voltage, and the ammeter measures the current. So based on these three readings, we are supposed to calculate these two based on this circuit. Again, there are two methods. One is the cosine theta method, I call it. The other one is the Pythagoras theorem method. Okay, let's start with cosine theta method. P equal to VI cosine theta. Okay, PSC, short circuit power, short circuit voltage, short circuit current. And you have these three readings. You do not have cosine theta, so cosine theta can be found, and theta can be found. Right? Then you substitute the theta into the ammeters. Right? And you don't make it into rectangular number. Do not make it into rectangular number. And don't stop here. Again, that's the difference between open circuit test and short circuit test. Then the methods continue by finding the impedance. Alright, impedance. Impedance is equal to voltage divided by current. Which voltage? Total voltage is VSC 0 degree. Total current is ISC minus theta. That's where you plug this whole thing here into here. So with that, you have your polar form of your impedance, and then you make it into rectangular number. From here, then you make it into rectangular. Polar number make it into rectangular number, and that is where the answers come out. Okay? So that is the two values that you find. Remember, objective was to find this. Right? So that's called the cosine theta method. Right? We call V equal to VI cosine theta, find cosine theta, find theta, substitute theta into the current with the minus sign. Don't make it into rectangular number. Use Ohm's law. V over I. Polar number, impedance, make it into rectangular number. The answer is out. Okay, so that's the first method of short circuit test. Let's go to the second method, which is Pythagoras theorem method. Right? Now, Pythagoras theorem method starts with your power is equal to I square R. Because this is a series circuit, to find power, the real power, the best formula is I square R. I square R. Whereas open circuit test just now, the method was V square R because it was parallel circuit. Parallel circuit, the best method is V square R. Series circuit, I square R. Okay, so which I? ISC. Which R? REHV. I have my power meters reading and my ammeters reading, so R can be found. So I found the equivalent winding resistance at the high voltage side. Right? The next step is to find the impedance. Impedance V over I. Which V? VSC. Which I? ISC. Alright, you got the two readings, right? So that's to be found. And if you recall, impedance triangle is a right angle triangle. Yeah, impedance triangle is a right angle triangle. This is your REHB, this is the XEHB, and that is the ZEHB, right? Remember, impedance triangle Z is equal to R plus JX is a right angle triangle. So therefore, Pythagoras theorem can be used, right? And XEHB square is equal to ZEHB square minus REHB square. Yeah, so XEHB is therefore square root of ZEHB square minus REHB square. Right, so with that the answer is out. Okay, and that's called short circuit test. Short circuit test is an experiment performed to find equivalent resistance at the high voltage side and the leakage reactance at the high voltage side. The equivalent circuit is a series circuit. And there are two methods to find these two answers. One is the cosine theta method, the other one is the Pythagoras theorem method. Now you stick to the method. In other words, for open circuit test, if you use cosine theta method, short circuit test, you also use cosine theta. So you won't get confused. Right? If you use Pythagoras theorem for open circuit test, you also use Pythagoras theorem for short circuit test. Okay? Alright, now let's try to plug in some values and as a revision to find the answers. Okay? Right, so take this away. So let's say the short circuit test power is 36 watt and the short circuit voltage is 28 volt and the short circuit current is 2.27 ampere. Right? Then you are given this data and you're asked to find this. And you have decided that you want to use cosine theta method. So what do? You say PSC equal to VSC, ISC cosine theta. So that is 36 equal to 28 times 2.27 times cosine theta. So cosine theta can be found using calculator, theta can be found. Substitute this theta into the current. So ISC minus theta. Yeah, which is 2.27 minus theta, the value that you find. Right? Then find impedance, which is equal to VSC 0 degree over ISC minus theta. So that will be 28 0 degree divided by 2.27 minus theta that I found. Right? So you have a polar form. Polar form. Then you make it into rectangular form, and that's where the answer comes out. Got it? So that is short circuit test. Okay, thank you.